Chapter 9, Section 1, Day 2, The Basics of a Significance Test. To finish up this section, we will look at two types of errors that can be made when a significance test is carried out, and the relationship between significance level, probability of a type 2 error, and something called power. When we draw a conclusion from a significance test, we hope our conclusion will be correct. But sometimes we're not going to be correct when we make a conclusion. There are two types of mistakes that we can make. We can reject the null hypothesis when it is actually true. That's known as a type 1 error. Or we can fail to reject the false null hypothesis, and that would be a type 2 error. So the definition of the two types of errors. If we reject the null hypothesis when the null hypothesis is actually true, we have committed what's called a type 1 error. If we fail to reject the null hypothesis, when the null hypothesis is false, we've committed a type 2 error. Here is a chart to indicate all the conclusions that we can make, both correct and incorrect conclusions. You can notice at the top of this chart, it gives you the truth about the population. The null hypothesis can be true, or the null hypothesis could be false. Notice on the left-hand side is the conclusions that are based on the sample that we've taken. We can either reject the null hypothesis or we can fail to reject the hypothesis. In looking at these four different quadrants, if we have rejected the null hypothesis, but the null hypothesis is actually true, we've committed what's known as a type 1 error. If we've rejected the null hypothesis, and the null hypothesis is false, that is a correct conclusion. If we fail to reject the null hypothesis, and the null hypothesis is true, that is a correct conclusion. And if we fail to reject the null hypothesis, because the null hypothesis and the null hypothesis is false, that is another error, and that's a type 2 error. Let's look at this example. Perfect potatoes. A potato chip producer and its main supplier agree that each shipment of potatoes must meet certain quality standards. If the producer determines that more than 8% of the potatoes in the shipment have blemishes, the truck will be sent away to get another load of potatoes from the supplier. Otherwise, the entire truckload will be used to make potato chips. To make that decision, a supervisor will inspect a random sample of potatoes from each shipment. The producer will perform a significance test using the following hypotheses. The null hypothesis will be P is equal to 0.08. The alternative would be P is greater than 0.08. The proportion P is the actual proportion of potatoes with blemishes in the given truckload. In looking at this example, I want to describe a type 1 and type 2 error in the setting and explain the consequences of making each type of error. Remember, a type 1 error is rejecting the null hypothesis when the null hypothesis is true. So, in context of the problem, a type 1 error would occur if the producer concludes that the proportion of potatoes with blemishes is greater than 0.08 when the actual proportion is 0.08 or less. The consequence of this would be the potato chip producer sends a truckload of acceptable potatoes away, which may result in a loss of revenue for the supplier. Remember, a type 2 error is failing to reject the null hypothesis when the null hypothesis is false. So in context of this problem, a type 2 error would occur if the producer does not send the truck away with more than 8% of the potatoes in the shipment and they have blemishes. The consequence would be the producer uses a truckload of potatoes to make potato chips. More of the chips will be made with blemishes, which may upset the consumer. Trying to calculate the probabilities of committing these errors can be difficult, especially when you're looking at the type 2 error. We can assess the performance of a significance test by looking at the probability of the two types of errors. That's because statistical inference is based on asking what would happen if we did this many, many times. For the truckload of potatoes in the previous example, remember we were testing the null hypothesis of p being equal to 0.08 and the alternative p being greater than 0.08, where p was the actual proportion of potatoes with blemishes. Suppose that the potato chip producer decides to carry out a significance test based on a random sample of 500 potatoes using a 5% significance level. In other words, alpha would be 0.05. Assuming that the null hypothesis is true, the sampling distribution p hat will have a shape that would be approximately normal, because n times p and n times 1 minus p would both be greater than or equal to 10. The center of the sampling distribution would be our p value, which is 0.08, and the standard deviation would be equal to the square root of p times 1 minus p divided by n, or 0.0121. Here is the graph of what the sampling distribution would look like. Also notice that there has been a green line on here placed where 0.05 is to the right of that. That is my alpha value. Anything greater than this point, where 0.05 is the area under the curve at the top part of this, we would reject the null hypothesis. Anything to the left of this green line, we would fail to reject the null hypothesis. Now we could use our normal probability calculations and calculate the p hat value for this rejection level, and it would end up being 0.0999. The shaded area in the right tail is 5%. The sample proportion value to the right of the green line at 0.0999 will cause us to reject the null hypothesis, even though the null hypothesis is true. This will happen in 5% of all possible samples. That is, the probability of making a type 1 error is equal to 0.05. So to find the probability of calculating a type 1 error is really easy, because you are the one that sets the significance level. Whatever the significance level is what the probability of a type 1 error will be. So the significance and type 1 error, the significance level alpha and of any fixed level test is the probability of a type 1 error. That is, alpha, the probability of the test, will reject the null hypothesis when the null hypothesis is actually true. Consider the consequences of a type 1 error before you choose the significance level alpha. Calculating a type 2 error is more difficult. A significance test makes a type 2 error when it fails to reject the null hypothesis that is really true. There are many values of the parameter that satisfy the alternative hypothesis, so we concentrate on one specific value. We can calculate the probability that that test does reject the null hypothesis when a certain alternative value is true, and that is the value we are going to select and concentrate on. This probability is called power of a test against a specific alternative. The definition of power: the power of a test against a specific alternative is the probability that the test will reject the null hypothesis at a chosen significance level alpha when the significant or specified alternative value of the parameter is true. Power, therefore, is a good thing. It is the probability that we will reject the null hypothesis when in fact some alternative value is true. For a good significance test, we want the power to be at least 80%, or 0.08 as a proportion. So back to the example of the potato chips, and we'll try to take a look at a type 2 error here. The potato chip producer again wonders whether a significance test of H0 being 0.08 versus the alternative P being greater than 0.08 based on a random sample of 500 potatoes has enough power to detect a shipment with say 11% blemished potatoes. This is that value that we're going to concentrate on. This is an alternative value that we're going to use. In this case, a particular type 2 error is to fail to reject the null hypothesis of 0.08 when in fact the proportion of blemished potatoes is actually 0.11. So earlier, we decided to reject the null hypothesis at alpha is equal to 0.05 if our sample yielded a sample proportion to the right of the green line. Remember, our p-hat value was 0.0999. That's where we rejected if 0.8 was actually true. What if p is actually equal to 0.11? So if you look on our graph over here, 0.11 would be in this area here. So if I redrew my distribution, keeping my reject value at 0.099, but moving my center of the distribution from 0.08 to 0.11, my graph would look like this. Remember now, we are rejecting to the right of the green line, and we're failing to reject to the left of the green line. If we ran through the probability calculations, the area to the right of the green line on this new distribution would be 0.7517. This is the power of the test, and the area to the left would be 0.2483, and this is the probability of calculating a type 2 error. The power of a test against any alternative is 1 minus the probability of a type 2 error. That is, power is equal to 1 minus beta, where beta is the variable now we're going to use to represent a type 2 error. When you plan a study and need to determine how large a sample you should take, the answer depends on what alternative values of the parameter are important to detect. Here are the questions we must answer to decide how many observations we need. First, significance level. How much protection do we need against a type 1 error? 2. Practical importance. How large a difference between the hypothesized parameter value and the actual parameter value is important in practice. 3. Power. How confident do we want to be that our study will detect a difference of the size we think is important? To summarize the influences on the question, how many observations do I need? First, if you insist on a smaller significance level, such as 1% rather than 5%, you have to take a larger sample. A smaller significance level requires stronger evidence to reject the null hypothesis. If you insist on higher power, such as 99% rather than 90%, you will also need a larger number in your sample. Higher power gives better chance of detecting a difference when it's really there. At any significance level and desired power, detecting a small difference requires a large sample. This is the end of Introductions to Significance Test. In Section 2 and Section 3, we will get into more of the mechanics on how to actually perform the significance test for both proportions and for means.